Alright, welcome back. Welcome back to the first tutorial. So if we see what we're going to be covering today, we're going to cover the fundamentals of machine learning. And if we check out what is there exactly, we have intro to machine learning, types of ML systems, linear regression example, and last but not the least, the challenges of machine learning. So let's go ahead, shall we? Alright, so let's quickly understand the definition of machine learning. So here I have a definition laid out for you. I'll read it. So machine learning is the science and art of programming computers so that they can learn from the data. Okay, what do we understand from this? Machine learning is the science and the art of programming computers so they can learn from data. Alright, let me also read another statement. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Okay, now it makes a little more sense, isn't it? So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So we are telling that machine learning is the field of study that helps or gives the computer the possibility to learn on its own without us telling how to learn, or without us telling the different aspects of what is to learn, right? Okay, let me also um, go ahead with a little more complicated one. This is the engineering oriented one. um, Let me just read it out. A computer program is set to learn from the experience E with respect to some task T and some performance measure P. So understand, the experience is denoted as E and the task is denoted as T, and the performance of the task is denoted as P. So we're saying if the performance on T, so that is the performance P on the task T, improves with the experience E. So what does it mean here? I know it is a little complicated, but all that the author is trying to say here is a computer program will learn if we rapidly increase the experience based on some task, and increase or increase the performance based on some task and the experience. So if the performance keeps on increasing, right, the performance P keeps on increasing with respect to the experience and with respect to that particular task, then we can say the computer program is learning. Make sense? I hope that makes sense. So let me just reiterate. We can say a computer is learning, right, if the performance P on some task T with the given experience P improves over time. That's what the author is trying to say. So in a nutshell, machine learning is the art and science of programming computers so they can learn from data. So let me also give you my definition of machine learning. So machine learning simply means that you are telling your machine or your computer to learn from a given set of data, so that when the new data comes in, it can predict, or it can say, hey, this is what it is going to be. Right now, if you take an example of weather forecast, you might have seen, right, so there has been a forecast for the next 10 days, or maybe even for 2-3 months from today, right? So how does that happen? So with the given history of data, right, so we are giving so much history of data to the machine, and then we are asking, hey, now with this given data, why don't you tell me what is it going to look like in the future, right? So it might be accurate, it might not be accurate, but at the end of the day, that is what machine learning is. So with given some data, we want the machine to understand, extrapolate, and analyze the different patterns of the data so that it can make good predictions on the new data. All right. So let's take a look at the traditional versus the ML approach. Now, what do I mean by traditional approach? Traditional approach means, yeah, let's take a look. So in traditional approach, we study the problem, right? We write the rules, we evaluate on the performance. If there is, I mean, if something is not good, we analyze the errors and again study the problem, write the rules or update the rules in this case after the first iteration, and then evaluate. Again, doing this couple of times, when we reach a good amount of performance measure, we launch that product or we launch that application, right? So this is the traditional approach. So everything here is very much defined so that the computer can know what are the next actions to take, and the programmer is the one who's going to be defining all the steps, no matter what the edge case is. So he's going to define all the edge case and define all the steps before we can see the performance that is good, and before we launch that product or the application. Now if we take a look at the machine learning approach, right, it's the same thing, but quite 2-3 aspects differ here. So in the machine learning approach, we study the problem, all right, we train an ML machine learning algorithm by feeding some data on it. So we study the problem, right? So we feed the relevant data to the problem, to a machine learning algorithm. We evaluate the performance. Now, of course, in the first iteration itself, it won't do good. We have to analyze errors and then again study the problem, why the error occurred, and then feed in more data, right, and then train the algorithm, train the machine learning algorithm. And doing this repetitively, we of course will get good performance, and then once that is done, we will launch the program or we launch the application. So you see that all we are doing here is we are giving extensive amount of data to the ML algorithm, and ML algorithm is going to figure out what is the best rules that it has to write on its own. So here we write the rules explicitly, but for an ML algorithm, we don't write the rules explicitly. All we do is we give the data, and the algorithm will figure out based on the data what the rules are and how to extrapolate based on the given data to the new set of data that might come. And doing this iteratively, we can we of course analyze the errors, study it again, give in more data, train the algorithm, and then again we do this iteratively. Then at one final time we will get good performance measure, and then finally we launch it, right? So that is the difference between the traditional approach versus the machine learning approach. So we can see that ML algorithm makes our lives easier by writing the rules automatically, just by giving enough ample amount of data. But what is an issue is the data itself. So we need to gather the relevant data for the problem, and then pre-process it to the algorithm the way the ML algorithm needs it, and then train it. So that is the only drawback of machine learning. We'll get there, don't worry, we'll get there. All right, now with that being said, with the basic understanding of the traditional approach versus the machine learning approach, let's see what are the different types of machine learning systems there exists. Let me just zoom out a bit. All right, I hope you guys can see. So different types of ML systems. So we have supervised, right, unsupervised, semi-supervised, reinforcement learning, instance-based learning, model-based learning, right? So we have 6 different types of ML systems. So let's take a look at what each of these mean. Do keep in mind, this is very crucial. In the ML world, people will just throw out random words like it's supervised, unsupervised, it's based on reinforcement or RL, instance-based, model-based, so on and so forth, right? So we need to be well equipped to understand those terminologies so that it won't be a jargon for us. All right, so let's understand what supervised means. So in a nutshell, in supervised learning, the training data you feed to the algorithm includes the desired solution, that is called as the label. So an example would be a typical supervised learning task is classification. The spam filter is good example of this. So if we take a look at our Gmail, right? So you can see that our Gmail automatically classifies whether our Gmail automatically classifies whether the given mail, right, is spam or not spam, right? In this case, ham is not spam. So the Gmail automatically does that for us, and that's why if you see your spam folder, it would have automatically categorized those mails. Now the question is, how does that Gmail know which mail is spam and which mail is ham, right? So this is a typical example of supervised learning. So based on different labels, that is the output we have, given the mail, uh, we can say this mail is spam or ham, right? So that's how the data is going to be. So the data is going to look like we have one mail and the corresponding output of that mail. That is whether the mail is spam or ham. And if we give ample amount of such data, we call this as supervised learning. So meaning that the output label for the question, there exists an output label, right? So given the mail, we have its corresponding label as spam or ham. So that is an example. So here you can see the training set consists of the instance and the label. The instance and the label. So label is whether it's ham or spam, and instance is the Gmail that comes, the Gmail that is categorized, the mail, content of the mail, right? So if the content of the mail says some gibberish and something is irrelevant, it's more likely that it is spam. But if it has some meaningful content and some important content in it, it will be categorized as not spam. So that is what supervised learning is. So basically, in a nutshell, when you give it to the algorithm also expects its corresponding label for that instance, right? So that is what supervised learning means. Alright, you guys can check this notebook out. This notebook will be given for you in the resources folder. You guys can check it out. Now here we have different types of supervised learning techniques: K nearest neighbors, linear regression, logistic regression, support vector machines, decision trees, and random forests, and finally the neural networks, right? So these are the different types of supervised learning techniques. We are going to do regression problem as an example, so don't worry about that. Now I hope you guys have some understanding of what supervised learning means. Alright, now let's take a look at unsupervised. Now, as you guys might have already guessed, unsupervised is the exact opposite, where we have given some instance, right? We have instance, but we don't have the corresponding label for it. So all we have is the training set without the label. So if we read out the definition, in unsupervised learning, as you might have guessed, the training data is unlabeled, right? The system tries to learn without a teacher. So all that we are trying to do is we are trying to cluster it and we're trying to group it, right, based on different attributes, but we will not have been given the explicit label for that particular instance, so to speak. Alright, an example would be, so let's say for example you have a lot of data about your blogs visitors. So let's say you're developing or writing blogs constantly, maybe on Medium, right? And then you can see different people who visit your to read your articles. Now you might want to run a clustering algorithm to detect the group of similar visitors, right? So now you might want to understand how similar are these visitors. So are they from completely different background, or are they from the same background, and that's why your blog is interesting to them, only to those specific set of people, whatnot, so on and so forth. So that is one best example of clustering or unsupervised learning. So we cluster it. I mean, when I say cluster, we group them into different classes by the model itself. Whatever the model thinks is best group, it will cluster them and then say, hey, this is the first cluster, second cluster, and third cluster. So if a new data comes in, it checks out its attributes and then sees the best match where this new attribute will go inside of which cluster, and then puts it inside that cluster. Alright, I hope that makes sense. So we have clustering, so it's k-means, dbScan, and HCA, and also we have anomaly detection and novelty detection, one class SVM, isolation forest. Don't worry about all those. We will be going through the clustering, which is what we need. So clustering is an example of unsupervised learning. All right, now semi-supervised learning. I think you guys can also guess what semi-supervised learning could mean. So semi-supervised learning means we have partially labeled training data, and also we don't have the labeled data as well. So in the training data we have partially labeled, and also we have a lot of unlabeled data as well. So this is called as semi-supervised learning, where we have some part of labeling and the rest is unlabeled. So we have to figure that out, and then again cluster them or group them into different classes. The best example would be your Google Photos. When you upload photos, it asks you, which if this person belongs to, or it'll automatically tell you that this photo belongs to this person, or a person A, person B, right? So all you have to do is just name that person, and then you have labeled it already. So that is how the semi-supervised learning works. If I have to read it out, once you upload a photo, all your family photos to the service, it automatically recognizes that the same person A shows in photos number 1, 5 and 11, while another person B shows up in the photos 2, 5 and 7. Well, of course these numbers are arbitrary, but this is just to prove the point, right? This is the unsupervised part of the algorithm, that is the clustering. It will cluster based on different attributes of that photo, and of course the photos are basically arrays, and if they, if some attribute of those array match, then they will be clustered into person A, person B, person C, so on and so forth. And now all you have to do is to just label one label for that person, and you have just basically created the supervised learning part of it. Alright, with that being said, we understand what is supervised learning, unsupervised learning and semi-supervised learning. Now reinforcement learning, this is something completely off topic. Well, not off topic, but they have nothing to do with these different supervised, semi-supervised learning. They are quite different in the way it works. So the way it works is, we have an agent in a particular environment, right? So the agent will observe the environment, select the action policy, take the action and gets rewarded or gets penalized, and then updates the policy and then iterates again. So what is actually happening here is, the best example I can take is a baby, a newly born baby, right? It's trying to learn what what it should do. Now it knows that if it cries, that it will get food. If it is not crying, people will not give it food. So the only way it knows that it needs to, the only way it knows to get rewarded is that given a particular environment, that is when it is hungry it will cry, and when it is not hungry it will not cry. So it observes it and then takes that action, right? So that's how it works. Or we can also take another example where the robot, you put it in a particular environment, maybe your house or your field or whatever it could be. It understands that this is whatever it does, it needs to either be rewarded or it will get penalized, and then of course we want it to be rewarded, right? So it takes those actions where it gives more, it gets more rewards, and then takes those actions and then updates the policy, so to say. Or maybe another last example would be your dog. So when your dog is misbehaving, you're going to say you're a bad dog and you won't give it food or something, right? But when it is behaving good and it is listening to you and all that stuff, you reward it with food, right? So it knows that if it is doing what you asked to do, you will give it food, but if it is doing something that you don't want, you will not give it food. So obviously the dog, over iteration, it will understand, that is, it will update its policy to behave good and then get rewarded for it. That is what is reinforcement learning doing. That is what in a nutshell. And if you look at the reinforcement learning space, Google's DeepMind created a program called AlphaGo that ended up beating the world champion Key G. I don't know if I'm pronouncing it right. in May 2017. So Kiji was renowned Go AlphaGo player, and I do keep in mind AlphaGo is not easy to play even for humans. It takes a lot of calculation and a lot of foreseeing, but the AlphaGo, I mean the DeepMind's AlphaGo beat the world champion Kiji at the game Go. So you can see how reinforcement learning can also be applied in real life scenarios. Also, a quick tip: do follow DeepMind and OpenAI. They are the best research firms out there. So do follow them and do keep a check on what's going on in the latest of deep learning. All right. So coming to the next type of ML systems, we have instance-based learning. So really, the instance-based learning in a nutshell is, we have given different instances. Now, based on those given a new instance, it just has to generalize by comparing the given training instances. So we can see this box here is more likely to get generalized to, or more likely to get into this triangle class because it is closest to it. So that is how instance-based learning works. So let me just read it out quickly. The system learns the examples by heart, then generalizes to new cases by comparing them to the learned examples or the subset of them using a similarity measure. So you can maybe think that it could take the Euclidean distance or some kind of similarity measure given the new instance. How does it relate to the existing training instance? That's what instance-based learning does. And then last but not the least, another way of learning is model-based learning. So in model-based learning is that we generalize a model to the existing instances, and then we make the model predicted. So here in instance, don't get confused. In instance, we're just taking the Euclidean distance or some kind of similarity measure. Whereas in model-based learning, we are going to train a model that will model on the existing data set, and when the new instance come, that is the predictions, it will predict where the new instance is best fitting to, whether does it fit to class A or the triangle or the square. So those are the different types of machine learning systems. So do keep in mind about especially supervised, unsupervised reinforcement learning. Now there is also new advancements coming up. It's called as self-supervised learning, meta learning, all those great good stuff, but we're just in the beginning. So these are all the essential things that you need to know, the basics you need to know. But yes, so all the resources files will be given to you in the resources folder. You guys can check it out and go through these theory part of it, so that you guys have a good understanding of different terminologies and different types of ML systems. So I'm going to stop it here. In the next lecture, we are going to quickly understand what linear regression is, and then we are going to do some regression using scikit-learn, right? And we'll download some GDP data and then understand the how people's lifestyle changes based on the GDP of the country. All right, it's going to be a little exciting. So we'll see you there. I hope you guys are enjoying this tutorials and you get the value out of it. All right, see you in the next tutorial. Bye bye.